Taylor and Maclaurin series. All right. In the previous section, we did introduce the Taylor series expansion. So now we're going to look at more functions. How do you write more of the general function like sine x, cosine x, e to the power x? We did look at e to the power x. Okay, look at more of the formulas for these two expansion. For example, this is kind of a review of the previous work before we give the give the formulas. So if a function has the derivatives of all orders at x equals c, okay, if a function f has derivatives of all orders at x equals c, then the series then from 0 to infinity then factorial fn power fn c x minus c to power n equals fc plus fc prime times x minus c plus until n factorial fn c x minus c to power n plus. Okay, so this is a Taylor series at x equals c. The Taylor expansion, right, is called Taylor series for fx at c. Okay. Moreover, this is a review of previous section work. Previous, I think the beginning, 9.8. If c equals 0, then the series is a special case. The series is called the Maclaurin series for f. Okay. So let's look at an example. So if it's c equals 0, you're going to have something like this. fx equals f0. Because this is the Maclaurin series, you have fx equals f0 plus f0 prime times x minus 0 is x, plus second derivative f0, because c equals 0, right? Since c equals 0, and times x squared over 2 factorial, plus third derivative of 0 times x cubed over 3 factorial. You can continue. Okay, it's fn factorial over 0 times x power n over n factorial. So then we use this formula to find the Maclaurin series for sine x. We just need to find the f0, f prime of 0, f prime 0, f third derivative 0, f nth derivative 0. That's what we need to do. Okay, so we got fx equals sine x. The derivative of sine x is, I'm going to call a student to complete that. So the derivative of sine x, I'm going to call a student here. What's the derivative of sine x, Zijian? Okay, continue please. Second derivative, negative sine. Third derivative, negative cosine x. Fourth derivative, sine x back to itself. Okay, so can you tell me what is f0? 0. F prime of 0, 1. F second derivative 0. Fourth derivative 0. Third derivative 0. Fourth derivative 0. Okay, 0. Very good. You have 0, 1, 0, negative. You continue. It's going to be 0, 1, 0, negative 1, 0, 1. The fifth derivative is going to be 1 again. So it's kind of like this is a period. Okay, it goes back to 0 again. All right. So we just plug in this into, we plug all these numbers into the formula. We got sine x equals 0 plus x, first derivative is 1, replace this 1 is x, second derivative is 0, so it's plus 0 minus plus 0, and then third derivative is minus 1, so it's minus an x cubed over 3 factorial, then plus. I'm going to ask the student to finish this. So, Thea, could you please continue with this? So what's the next? Plus 0. Then next. Perfect. What's next? Plus 0. What's next? Seven. Because the 6 is right here, right? 7. Okay. So I think you got thank you very much. I think you got this x cubed 5 7. So you only have the odd power coming out. All the even derivative goes to 0. So we can summarize it in a more generalized form. We only have odd numbers. 1. This is actually 1. 1 factorial 1 3 5 7. So I would like to continue ask another student tell me what I put here. So I'm going to call a student here. Matthew, could you please tell me what do I put in the numerator? This is 1 3 5 7.
I am unsure and all.
So how do you represent the odd numbers? Give me something, tell me 1, 3, 4, 5, 7, 9, 11, 13, 15.
2 plus 1.
2n plus 1, that's perfect. 2n plus 1 factorial. Okay, so x to what power?
Could be 2n.
Okay, this is the same power, look, 1, 3, 5, 7.
2n plus 1.
2n plus 1, very good. Okay, there's another thing I need you to continue. Look, this is positive, negative, positive, positive, negative. You have back and forth. So positive is the this is the first term, second term, third term, fourth term. So negative 1 to what power?
Could just be to n, wouldn't it?
To n power. Very good. Okay. All right, so let's see. Then we can look at the this is the Maclaurin series. We're done with it, but sometimes it might ask you for the convergence radius. What you can do is limit n goes to infinity, am plus 1 over am. So you got you only look at this, so it's going to be negative 1 to the power n times x to 2m plus 3 factorial times negative 1 to the power n x to 2m plus 1 factorial. Basically, you use am plus 1 over an and you simplify. That's what we did before. Simplify to get x squared. Limit x n goes to infinity. N goes to infinity x squared over 2n plus 2 times 2n plus 3. So this is the infinity and equals 0 as n goes to infinity. So no matter what x you choose, this is always 0. So the convergence radius is x is from negative infinity to positive infinity. Okay, so that's the convergence radius for this series. All right. Now I want you to do one by yourself. Okay. Example. Find f(x) equals e to the power x, the Taylor series. Okay. Find Taylor series. For f(x) equals e to the power x at c equals 1. Okay, I'll give you 3 minutes to try it by yourself. You use the formula I give you. You use this formula. Use this formula. Okay, are you done? Alright. So e to power x, I'm going to ask the student to tell me here. So Taylor, could you please tell me how you did it?
I wasn't too sure how to go about this one, but I know that each subsequent derivative is just going to be e to the x.
Okay, so fx is e to power x, and we're looking for the c equals 1, so you can write this as e to power x. So because fx is e to power x, you write down e to x, so it's just f1 plus f1 prime x minus 1 plus f1 second derivative x minus 1 square 2 factorial f third derivative at 1 x minus 1 cube of 3 factorial. So you have nth derivative at 1 x minus 1 to power nth factorial. Okay, so I will have to continue to ask you, Taylor, could you please tell me what is f1?
Just 2.7.
Yeah, it's just the e to power 1, so it's the e, right? What's the f prime of 1?
E times x minus 1 over 1 factorial.
Okay, it's still e, yeah. Because the derivative e to power x, derivative is itself. It don't change because it's e to power x. So it's still, prime of 1 is still e, so it's e x1 over 1 factorial plus, it's e x minus 1 square 1 factorial plus, sorry, 2 factorial, 3 factorial e x minus 1 cube. So all of them have a common factor, which is e. I can take the e out. Then m from 0 to infinity. So this is 0, 1, 2, 3, 4. Actually, you can do 0 here, 0 factorial. So now I would like you to tell me what is the common series. Taylor, could you please tell me? This is 0, 1, 2, 3, 4, and from 0 to infinity. So what do I put here?
X minus 1 factorial.
X minus 1, this is the top. This is 0 power, 1 first power, second power. So this is the first term, 0. Okay, so you can change. Yes, it's e times x minus 1 to power 0 over 0 factorial. So you can look 0, 1, 2, 3. So you have, this is e, take it out, x minus 1 to power m. Because m from 0, 1, 2, 3, 4. And 0, 1, 2, 3, 4. So it's just the m factorial. So that's it. Then we're done. Okay. I think it asks you for, sometimes you have to find the convergence radius. Take the limit of an plus 1 over an, then it's not really hard for that. So what do we do? I'll give you more kind of formulas that you can use. The book also gives you formulas too. So the power series for elementary functions. The meaning of elementary functions is the functions we use a lot, like common functions. Okay. For example, these are formulas. Okay. 1 over x equals n from 0 to infinity, negative 1 to power n, x minus 1 to power m. In the test, I probably will not give you the formula. I won't, because what you need to do, you only need to memorize this formula. You only need to memorize this formula, which is not really hard to memorize, because the first derivative, second derivative, you memorize that. Maclaurin series is c equals 0. But if I ask you to find my Maclaurin series, I'm going to just say at c equals 0. So this is the only formula you need to memorize and understand. It's not really hard to memorize it. Everything else, I probably ask you to find it by yourself. Okay, we'll find 3 terms, 4 terms, like that. 1 over x, 1 plus x is n from 0 to infinity, negative 1 to power n, x power n. This is x less than 1, bigger than negative 1. And ln x, which is n from 0 to infinity, n times negative 1 to x minus 1 to power n. 0 less than x less than equal to. E to power x is from 0 to infinity, n factorial x power n. And x less than infinity bigger than negative infinity. Okay, so sine x equals n from 0 to infinity, negative 1 to power n, x power 2n plus 1, 2n plus 1 factorial, negative infinity less than x less than positive infinity. We also have cosine x equals n from 0 to infinity, negative 1 to power n, x power 2n, 2n factorial, just the even terms. We did the sine x in the for one of the previous example. Cosine x is pretty similar. It's just the even terms exist. The odd terms are zeros, less than x, less than infinity. So these are the common expansions, like common series, common functions, like elementary functions, the power series. Okay, so let's do two more, I think. Arc tangent x equals x. Okay, just give you the final. N from 0 to infinity, 2n plus 1, negative 1 to power n, x power 2n plus 1, negative 1 less than equal to x, less than equal to 1. So arc sine x, which is n from 0 to infinity, 2n n factorial, 2n plus 1, 2n factorial, and x to 2n plus 1. The negative 1 less than equal to x less than equal to 1. And also 1 plus x to the power n, which is a binomial. And we have is n from 0 to infinity, and k actually is I. Why do I have infinity? It's just 0 to k, I think. I from 0 to k, ki, and x power I. And x is less than 1, bigger than negative 1. Okay, so let's look at some more examples. Okay. Derive the Maclaurin series for the function fx equals e to negative 3x. Okay, I'll give you like 3 minutes to try it by yourself. Okay, are you done? Okay, I think I'm going to ask a student here. Let me check who is done. So I will call student here. Jasper, could you please help me with this one?
F of x equals 2 to the negative 3x. F prime of x equals negative 3 to the negative 3x. Double prime of x equals times 2 to the negative 3x. And that third derivative is negative 27 to the negative 3x. So on. And then, so f of 0 is 1. F prime of 0 is negative 3. Then 9 is negative 27. So if you plug that in, you get e to the negative 3x equals 1 minus 3x plus 9x squared over 2 minus 27x cubed over 3 factorial. And so that pattern is the series from n equals 0 to infinity. Of negative 3 dn times x 3n all over n factorial.
Perfect. Very good job. Thank you very much, Jasper. Okay. So as long as you know how to do this Maclaurin series like this, what do we give you example like this? Give you a function, not a very complicated function, just a simple function. And in your exam, I probably just give you a simple function like this. Maybe it's not e function, maybe it's sine function, cosine function, either one of them, but the derivative is not really hard. And then you just follow this step, you'll be fine for this section in the test. Okay, so this is the steps to do it. But if, for example, if you memorize the formula, so the formula for e to the power x is here, right? Okay, so e to the power x formula is this. If you know that e to x equals n from 0 to infinity n factorial x power n. Look, this is x, this is x. Now, if I do e to negative 3x, what I need to change, I just need to change this part. N factorial, change the x into negative 3x. So you got one step, you can get n from 0 to infinity n factorial negative 3 to the power n x power n is exactly the same thing as this. Okay, so if you know the formula, you just need to, whatever it give you x, it can give you x squared, it can give you x power 4, it's okay. And you just need to change that part into the exponent. Okay, so you will get the same result. So for example, if I give you another one, if I ask you what is e to x squared over 2, like this, what is that? So what you need to do, you just need to change n from 0 to infinity n factorial x squared over 2 to power n. This is x, this is x, this is x squared over 2, this is x squared over 2. So you got this is going to be n from 0 to infinity. Okay, you can change that in 2 to power n factorial and x to 2n. So that's it. Okay. So no matter what I change here, e to 5x, e to 6x, you just need to change that x part into the exponential part. You change this function part, x part. That'll be enough. Okay. Alright, so next example. I want to try find the Maclaurin series for fx equals cosine 4x. Okay. I'll give you 3 minutes to do it. Well, actually, I will give you the formula for this one. If the formula is cosine x equals n from 0 to infinity, -1 to power n, 2n factorial to x power 2n. So can you find out cosine 4x? Okay, are you done? Alright, I'm going to call a student here and tell me how you did this one. Travis, could you please tell me how you did this one?
Well, I used the formula you gave.
Okay.
And you get from n equals 0 to infinity, -1 to the n, and then 4 to the 2n times x to the 2n over 2n factorial.
Okay, perfect. Okay, 2 factorial. You get x is less than infinity, bigger than negative infinity. Sometimes you, okay, if you don't memorize this, like ex cosine x sine x, you have this, okay, because there's no restriction here. And you can check it by yourself. Limit an plus 1 over an less than 1. You should be able to get this one easily. So that's perfect. That's very good. All right. So next example. Well, even for example, during the test, you don't memorize the formula. If it's a complicated function, probably I will give you the formula. If it's an easy function like sine x, cosine x, not sine x squared, but just sine x, cosine x, or sine 3x, cosine 5x, like those simple functions, I will not provide this formula. You need to do the first derivative, second derivative, third derivative, and write it out. Okay. If it's a very complicated functions, yes, I will provide that formula because you have more work to do, not just one step work. Okay. So the next one, for example, gx equals 2 sine x cubed. So given the x, given the sine x, you know why I don't want to use the formula to do this one? Because you take the derivative, it's going to be complicated. Because if you take the derivative, the first derivative is going to be 2 cosine x cubed times 3 sine x squared. Well, so first derivative is not bad. Second derivative, use the product rule. So you have this, you have one product rule, derivative of this times this, derivative of this times this, and the third derivative is more complicated. So you will not want to try the derivative with complicated functions. So we are going to just apply the formulas for the simple functions. For example, the formula is sine x equals from n from 0 to infinity, negative 1 to power n, x power 2n plus 1, 2n plus 1 factorial. Okay, so I would like you to work on this one. Given the formula is this, and you find the 2 sine x cubed. So I call another student here. Luke, could you please tell me what you got for gx?
Alright, so I use the formula, and you get negative 1 to the n, 2 to the 2n plus 1.
Oh, the 2 is outside of the sine x cubed, right? So I take the 2 out.
Oh, yeah, right. So then you just got x to the 6n plus 3 over 2n plus 1 factorial.
Very good, 2n plus 1 factorial. So still you got an negative over x, negative infinity, plus negative infinity. So that's perfect. You got 2. Let's just write a few terms. Sometimes you can write a few terms. I'll see how it looks. So first one is n equals 0, so it's x cubed over 1. when n equals 2, so it's going to be minus, so n equals 1, 3 factorial of x power 9 plus 5 factorial x power 15. You can write a few terms. You can see, okay, this is the expansion. All right. So next one more example on this one. Example: fx equals ln 1 plus x, giving you the function as ln x equals n from 1 to infinity, negative 1 to power n, x minus 1 to power n over n. The radius is 0 less than x less than equal than 2. Okay. At this time, you have to pay attention to the radius. Because the previous is negative infinity to positive infinity, you don't have to pay attention to the radius. But now this one, you have to. I'll give you 2 minutes to finish the expansion, and also I will ask you especially the radius, convergence radius. Okay, I think I'm going to call a student here to finish this. Is anyone done? Alright, so I'm going to call a student here. Eric, could you please tell me what you got?
Okay, so ln of x plus 1 equals from n equals 0 to infinity.
Okay.
Negative 1 to the n times x to the n over n.
That's perfect. Very good. Good job. Oh, no n factorial, my bad. So, what is the radius?
Between negative 1, or x is greater than negative 1 and less than 1.
Okay. Less than 1?
Yep.
Can I put an equal? Yes.
I'm not sure why.
Okay. So we do negative 1 to power 1, and why do we have positive 1? So what do? We can have limit n goes to infinity an plus 1 over an. I think that's pretty simple. You can get limit n goes to infinity. Okay, so everything will cancel out. It's xn plus 1 over n plus 1 times x power. The negative sign doesn't matter because you just get negative n plus 1. It's the absolute value. You'll always be positive. And n, so it's just the x. Okay, so we got x is less than 1. I got x is less than 1, bigger than negative 1. Check the endpoint. So if x equals negative 1, I have that this one equals n from 0 to infinity negative power n times negative power n over n, which is negative 1 to the power 2n, so it becomes positive. So it is 1 over n diverge. We got t-series. Well, if x is positive n, it's a little bit different. Because it's just the x equals 1. So x equals 1 plug in. It's a little bit different because it's 1 to the power n is just 1 over n. This converge because this is alternating series. Alternating series, I just need to check. N goes to infinity limit. N goes to infinity 1 over n equals 0. It's decreasing because 1 over n plus 1 less than 1 over n. So it converge. This one is okay. So that's why the convergence radius is negative 1 to positive 1, but the positive 1 is contained. Does that make sense, Eric?
Yes, thank you.
Okay, no problem. Alright, so I think we still have 2 minutes. I'll do one more. Sometimes you may have a function example hx, for example, equals x times cosine x. In this case, you don't need to worry about that because cosine x you can write as, suppose cosine x, we know the formula is cosine x equals from n from 0 to infinity, only even terms remain. So it's 2n factorial x to 2n. So what you need to do is just change that into n from 0 to infinity, negative 1 to the power n, 2n factorial times x power 2n. Since you have an x out there, so you can multiply the x by the 2n, you are going to have n from 0 to infinity, negative power n. The 2n becomes x to the power, I'm going to call a student here. Bella, could you please tell me what is the power? So this is 2n, there is an x here, what's my new power?
4n.
I have an x, I have x2n. So basically you have x times x2n. What's the new power?
x2n.
No, this is
x2n is 1.
okay, x2n plus 1. Thank you very much, Lacey. Yeah, it's x2n plus 1 because this is just x the first power. You add exponent, so x times x to 2n, so it's x to 2n plus 1. That's the only thing we need to do. Once I know the formula, let's multiply those two, and you got 2n factorial. So that's it for this. Negative infinity less than x. Thank you very much, Bella. So that's how we have the x multiply the function. That's the only thing you need to do. Okay. Maybe just one. We don't have time, but I have 2 simple examples, but I think that'll be enough. Okay. So we're gonna continue tomorrow. Finish this real quick, maybe 5 minutes. We can finish the whole section, and then we're going to move on to chapter 10, conics, parametric equation, and polar coordinates. Okay. After chapter 10, we only probably do 2 more sections on chapter 6. Okay. Then that's the whole thing for the whole semester for calculus 2. Thank you very much for coming. I'll upload this video online, but everyone's here. It's okay, you still can view it online. So I'll see you tomorrow. If you have any question, please let me know. I've assigned the homework in online. You should have your homework already. I will assign the chapter quiz soon, okay, which you can use for prepare for the test.